Hello everyone, and welcome to the Recommender Systems of Python lecture. In this lecture, we're going to show you how to create an item similarity recommendation system for movies. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the repository for the machine learning sections, and under the Recommender Systems folder, again you see two notebooks, Recommender Systems of Python and then Advanced Recommender Systems of Python. We're going to be walking through the Recommender Systems of Python lecture notebook that you can see here. And this is all the code we're going to be basically walking through and explaining as we go along. This is going to be essentially a portfolio project that we'll walk you through. And here we have the Advanced Recommender Systems of Python notebook. This is a code notebook for creating advanced recommendation systems of Python, but keep in mind that the level of mathematics and use of SciPy here is pretty advanced. So only go through this as an option if you want to actually see through linear algebra how you can create a more advanced collaborative filtering recommendation system. And there's pretty good text explanation on every single step as you go along, as well as just some images to help you understand what's actually going on. But keep in mind, it is pretty mathematical, so if you don't have that background, you can go ahead and feel free to skip this. Let's go ahead and jump right in to our own recommender system, which is going to be a little simpler, and it's going to be an item similarity based recommendation system. I'm going to go ahead and create a new notebook here. I would advise that you do the same. Again, you won't have all those options that I just have, because we're going to be using these three data sets here, u.item, u.data, and then this movie underscore ID underscore titles. All right, I'm going to go ahead and hide the head bar and the toolbar to give myself a little more room. Let's go ahead and get started. All right, I'm going to go ahead and start off by just saying import numpy as np and import pandas as pd. And then we're going to go ahead and get the data. First off, I'm going to create a variable called column underscore names, and it's just going to be a list of the column names. I already know these beforehand because I've done this before. Our first column is going to be a user ID. Then we're going to have an item ID. Then we'll have a rating. And then we'll have a timestamp. And what we'll go ahead and do is say df is equal to pd.readcsv, and we're going to pass in u.data. And it's going to be a tab separated file. So instead of just leaving it blank, I'm going to say sep is equal to \t. And then I'm going to set the names to column names. And I just did tab autocomplete there. And then let's go ahead and check the head of our data frame. All right, there it is. So here we have user ID, item ID, rating, and timestamp. And this is known as the movie lens dataset. And if you want to find out more information about the dataset, what you can actually do is go to the Advanced Recommendation Systems notebook of Python. And if you scroll all the way down to the bottom where it says looking for more, I've actually set you up with a bunch of links for other datasets where you can actually build off more recommendation system analysis. There's other movie recommendation datasets. We're going to be using a subset of this movie lens recommendation dataset, but you can see that there's other links here. There's also a music recommendation link for other datasets, book recommendation, healthcare, and dating. Now keep in mind, sometimes these sort of links get dropped or go down if people don't want to host those datasets anymore. So not all the links may stay up to host the data. As of now, I've checked and they're all working, but go ahead and post to the Q&A forums if you find the link that's no longer working, and I'll try to help you find that dataset again. Okay, let's go ahead and jump back to our original notebook. We have our data frame, and the data frame basically just says a user ID, the item ID, in this case it's a movie, the rating they gave that movie, and a timestamp for at what time they actually gave the movie that particular rating. What we're going to go ahead and do is grab the movie titles. So I'm going to say movie titles is equal to pd read underscore csv, and I'm going to pass in movie, and I can actually just tab autocomplete this to get movie underscore ID underscore titles. And if I just check out this movie titles just ahead of it, I basically have a correlation between the item ID and the actual title. And what we want to do is, instead of dealing with item IDs here, I want to replace that with some sort of title, or at least merge the data frames so I can have a connection between item ID and the movie title. That way I'm not just working with kind of meaningless numbers here. In order to do this, I will say df is equal to pd dot merge, and I'm going to merge the data frame and the movie titles, and I will do it on item underscore ID. And then when I check out the head of my data frame, now I have the relevant movie title for that particular item ID. So we can see the first one is the first Star Wars movie in 1977. Let's go ahead and explore the data a bit and get a look at some of the best rated movies just so we can kind of get a feel for the data. I'm going to do some imports here. Import matplotlib.pyplot as PLT. I'll import Seaborn as SNS. And I'm going to go ahead and say SNS set underscore style to white. Whoops. And since I'm using the Jupyter Notebook, I need to say matplotlib inline. All right, what we're going to go ahead and do is create a ratings data frame with average rating and number of ratings. Let me go ahead and show you what I mean by this. I will say df.groupby, and I'm going to group by the title column. Remember, that's the title of the movie. And I actually just want to grab the rating column and grab the average of it. So if I just do this, I have now the average or mean rating for every title by grouping everything by the title. Then what I can do is actually just off of this call sort values and then say ascending is equal to false and just check the head of this. And now this allows me to see the movies with the best ratings. Now keep in mind, we did do a group by here. So it could be the case that a lot of these movies here only have 1 or 2 people that saw it and happen to give it a 5-star rating. Let's go ahead and see the movies with the most ratings. So we'll say df.groupby. I'm going to group by the title. Again, I'm just interested in the rating column, so I'll just grab that. And then I'm going to say count. And then I'll say sort values. And we'll go ahead and say ascending is equal to false and just grab the head. And this lets me see which titles of the movies actually have the most ratings. So it looks like the most famous movies such as Star Wars, Contact, Fargo, Return of the Jedi, and Liar Liar have the most ratings, which kind of makes sense. If you've seen at least some American movies, you probably are familiar with at least one of these movie titles, versus I'm actually not familiar with any of these movie titles. So that actually makes sense. Let's go ahead and try to put this all into a data frame. I'm going to create a data frame called ratings, called equal to pd.dataframe. And then I'm just going to pass in group by title, and then say rating dot mean. So essentially what I'm doing is I'm grabbing what I did up here, except up here it returned a series after calling sort values on it. So I'm just going to go ahead and pass this all into a data frame just so it looks a little nicer for me. So if I go ahead and check out the head of this ratings, now I have an index based off of the movie title, and my rating is going to be a column with the value of the average rating. Now, something we noted earlier was that the rating kind of depends on how many people rated it, because seeing something is a 5-star rating doesn't really help if you only have 1 person that rated it versus 1,000 people that rated it. To get an idea of the number of ratings, let's go ahead and create a number of ratings column right next to this rating column. In order to do that, I'm going to do basically what I did up here, df.groupby title rating.count. I'm going to go ahead and copy this and then say ratings, put a new column in here that says num of ratings for the number of ratings, and I will set this equal to pd.dataframe and then just pass in what I had there. And now if I check out the head of ratings, I have the number of ratings and the average rating, with the index being the movie title. Now let's go ahead and explore this by doing just a couple of histograms. I'm going to go ahead and just do a histogram off the ratings, and you can do this with Seaborn or Plotly, whatever you prefer. I'm just going to use basic pandas built-in visualizations here. I'll say ratings, number of ratings, and just do a histogram. And since this data set's kind of large, I will say bins is equal to 70. All right, so now we can see here that most of our number of ratings are actually quite few. If we look at the movies, it looks like most movies have either like 0 or 1 rating, which kind of makes sense. Most people only watch the famous or big hit movies, these blockbusters. So those are going to be the ones with a lot of reviews or number of ratings. Now let's see the actual ratings themselves. So I'm going to say ratings, rating, which is going to be a histogram. I'll say bins is equal to 70. All right, so now we can see a visual distribution of the ratings themselves. You probably notice that there's some peaks at the whole number, such as 1.0, 2, 3, 4, and 5. And that kind of makes sense because just of the way people are going to rate movies. And these movies probably only have a few people watching them, or just one person who watched them, and happen to give it a whole number star, 1, 2, 3, 4, or 5. And then it looks like most movies are distributed kind of a little bit normally, around 3 stars, kind of 3.5 stars. And there's actually quite a number of outliers here of 1-star movies. Kind of makes sense because there's probably a bunch of just bad movies where only a few people watched it, just rated it as a kind of a garbage movie with 1 star, and happened to give it 1 star there. And you'll see there's a little peak here at 5 stars, and that's probably going to be the really popular movies or the movies that happen to have just one person watching it. Let's go ahead and do one more visualization to explore the data. Something we may be interested in is the distribution or relationship between the actual average rating and the number of ratings. What we can do is use Seaborn's joint plot to explore this. I will say sns.jointplot. I'll set x equal to rating, y equal to the num of rating column, or ratings, and say data is ratings, and then alpha is 0.5. Let me make sure I have this correct. Is it num of ratings? Yep, that's right. Let's go ahead and run this. Okay, now looking at this data, it looks like as you get more ratings, you're more likely to actually have a higher rating of a movie. And that kind of makes sense because if your movie is better, the better your movie, the more people that are going to watch it, and the more people that are going to watch it, the more likely you're going to have higher number of people reviewing or rating the movie. So this actual trend of more reviews, more ratings makes sense. And it makes sense that these 1 to 2 star movies have very few ratings versus these kind of better movies have a lot of viewers. Now you can see an outlier here at the 5 stars. And again, that's most likely due to just one person watching one movie, putting a 5 star on it, and that's it. Because even if you're a blockbuster and a fantastic movie, it's really unlikely that everyone's going to rate you a 5 star. Okay, now that we have a general idea of what the data looks like, we can go ahead and move on to creating a simple recommendation system based off of item similarity. We'll go ahead and explore that in part 2. Thanks everyone, and I'll see you at the next lecture.